Okay, so the last topic is called ambiguous triangle. So here's what's going to go on. I'm going to give you an angle. Okay, I'm going to give you an angle measurement. And I'm going to give you the side that's adjacent. And I'm going to give you the opposite side. And this is the third side. I don't know. That'll be a question mark. And there's a bunch of different rules we're going to go through. And it's all depending on what we know about this opposite side. Okay, longer, shorter. Okay, it's going to be a bunch of different situations. Okay, so this situation, do you see, because I gave you a side and then an angle, this is what I'm talking about there. So the SA situation can cause this to happen. Do you see it's different than SAS? I know it's using the same letters, but this is different than SAS because the angle is not on the inside of the sides, right? Okay, ready? If I give you this angle, the adjacent side is there. If the opposite side is longer than the adjacent side, it'll form one triangle. Okay, I'm going to try to do this like in an animated way here. See if I can use this, if it's going to work. Okay, so I have an angle. Okay, there's an angle. I'm going to give you that angle. So this side is the adjacent side. And over here would be the opposite side. And that's the third side I don't know. Okay, so this is what I just told you. If the opposite side is longer than that, there's only one possible triangle. So here's how it looks. Okay, ready? That's that side. Pretend I'm longer than it. Does this make sense? I'm longer. Where will it ever be able to touch? How many spots would a longer side touch? Just once. Does that make sense? Okay, let's do the next one. If the opposite side is really short, so, okay, there's the adjacent side. If the opposite side was this long, is it going to be able to form a triangle? No. Okay, so let's write that one down. Okay, so if the opposite side is shorter, and it's too short, then there is not going to be a triangle. So if I did sine law, so this would be a sine law, and I tried to get an angle, I would get an error. Okay, and the last situation, so I'm going to go back to this drawing. Okay, so if the opposite side is maybe just a little bit shorter, like here. Okay, so if I'm this length, but my opposite is about like that length, where can I make a triangle? What do you think? Did you see some spots? It could make this triangle. Or if I continue, it could have also made an option over there. Okay? So again, I just made the opposite side a little bit shorter, and then I realized, oh, it could have met there, or it could have touched there. Okay? So that's the third situation that could happen. So if this is the adjacent, and the opposite is a little bit shorter, there could possibly be two triangles then. Okay, ready? How many triangles are in this? Okay, so this is the opposite, because A is opposite of A. Okay, what are we? Opposite is, so we need to know, is the opposite bigger or smaller? It's shorter. So if it's shorter, I'm here. I have to do a sine law test. Either there's going to be too short, error, or there's going to be two. Okay, so I'm going to go like this. 8 over sine 33 equals 10 over sine B. And then I'm going to inverse answer, and then I either get my calculator to say an error or something. Okay, and I don't care what the value is right now, but I'm just looking, is it going to work or not work? So we all remember this. We're going to multiply, divide, right? Second sign, and did you get an angle, or does your calculator say error? An angle. So my answer is that I would actually have two triangles on this. So the triangle would be this situation where I'd be a swinging one. And it kind of makes sense to me, a 10 and then an 8. It's probably going to swing. Okay, second question. So A is opposite of A. So opposite is shorter. So we're going to figure out this side, sine law test. Is it too short, or is it going to make two? So I got to test it. So 5 over sine 28. 15 over sine B times divide and then inverse. So is it going to be an answer? Did it come to a number, or does it come to an error? And it's saying an error. So this is my conclusion. There's going to be no triangles. And it would kind of make sense to me if this was 15, 5 doesn't seem like it would be long enough to reach in a situation like that probably. Okay, third question. So A is opposite there. So which situation? Is this shorter or longer? It's longer, so guess what? That's the easier one, because then we don't have to do any work. If it's longer, right, there's only one possible spot that it'll touch if it moves around. Okay, number 4. Opposite side. So A is opposite. So I'm getting a longer, right? Opposite is longer. So 1 triangle is the conclusion already. Okay, number 5. Opposite is shorter. So once the opposite side is shorter, I'm going to test. So I'm going to run that whole sine law thing, and then second sign, does it work or does it make an error? Error. Okay, so now my answer is that there's going to be no triangles that will work. So it should say error when you second sign it. Okay, last one. So the opposite is 7, so it's shorter. Okay, so we're going to have to do that test again. So 7 over sine 35, 9 over sine B. Inverse. Does it produce something or does it produce an error is the question you would be asking yourself at that point. And did we get a number? So if I got a number according to the rules and the drawing, there'll be 2 triangles. Okay, so those are the 3 rules. So if the opposite is longer, there's only one possible. If the opposite is shorter, we'll do the sine law check. If there was an error, it's because that situation would be there's no triangles. And if there was a number, it'd be a swinging side.